Greetings, detectives. Mrs. McKay here, and let's go ahead and get started on case 4, sequence scenarios. First clue is I can determine whether a sequence, so go ahead and write the word sequence, is arithmetic or geometric or neither. I can determine whether a sequence is arithmetic or geometric or neither. Make sure you have all of that written in there. That's our learning target clue. Now, let's go over a few bits of vocabulary so that we can really understand what we're talking about. A sequence. A sequence is a series of numbers. A series is just a list. It's a list of numbers with a pattern. All right? So a sequence is just a series of numbers with a pattern that we can identify. Term is one number or member of a sequence. So if you have a sequence that looks like this, 1, 2, 3, 4, 5, each one of these is a term. Okay? And 1 is the first term, 2 is the second term, 3 is the fourth term. Okay? 3 is the third term, 4 is the fourth term. Okay, and then we have discrete and continuous. And remember that discrete is individual points or individual numbers, okay, separate. And continuous is everything. So in between, we'll say everything in between the points as well. So when you look at a sequence, I've got some sequences over here. On the right hand side, I've got a 1, 5, 9, 13. Would you say that that's discrete, or would you say it's continuous? If I was going to graph that, would you see individual points, or would you see connected points with everything in between? Well, it's discrete, isn't it? There's no 4 or 2 or 3 or 1.5 in between the 1 and the 5. There's a 1 and then there's a 5. And if I was going to graph it, it would be a 1 and then a 5. Nothing else in between. So there's no connection. It's not continuous. Okay? And then the last two things that we're going to talk about, let's write separate points here, is infinite and finite. So infinite means it goes on forever. And finite means it has an end. Okay? So infinite means it will go on forever. Finite means it comes to an end. So when we're talking about sequences, sometimes a sequence will go on forever and ever, and sometimes a sequence will have an end. It'll say, for example, if you had a problem like I'm setting up the chairs in the auditorium, and the first row has 2 chairs, and the next row has 3 chairs, and the next row has 4 chairs, and the next row has 5 chairs, and the next row has 6 chairs. Eventually I'm going to run out of room in the auditorium. I'm not going to be able to go on to infinity. That wouldn't make sense because the auditorium is finite. It has space, and I can only put so many chairs in there. So that would be a finite sequence. It might go up to maybe 25 rows. So it might be, or 25 terms, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 25. And that would tell me when my sequence ended. Okay. But if I am counting how often a cell divides or bacteria growth, that could go on and on and on forever. So so you need to understand the difference between finite and infinite sequences. One has an end, one doesn't. All right, now let's go ahead and get started on our looking for some patterns. So remember, a sequence is a series of numbers with a pattern. So let's look at this first one. Find the pattern 1, 5, 9, 13. Then that dot, dot, dot means it goes on forever, okay, and continuing. So 1, 5, 9, 13. Do you see the pattern? Well, to get from 1 to 5, I added 4, didn't I? And then to get from 5 to 9, I added 4 more. And when I got from 9 to 13, I added 4. So that's a pattern of adding 4. Yes? So what would be my next term? Well, it would be 17, right? Because I would add 4. Let's look at the next one. 3, 6, 12, 24. This is a sequence. Am I adding a number to get to the next term, to get to the next term in the sequence? Well, in this situation, I'm not. In this situation, to get from 3 to 6, I did add 3, but to get from 6 to 12, I didn't add 3, did I? I really multiplied by 2, didn't I? Let's make that a dot. And then to get from 6 to 12, I multiplied by 2. And to get from 12 to 24, I multiplied by 2. So I was doubling. So to get to the next term, what would that be? 48. That's right. Okay, let's look at this next one. 124 4/5. What's my pattern? Do you see it? Well, I actually divided by 5, didn't I? So from 100 to 20, I divided by 5, and I divided 100 by 5, and I got 20. If I divide 20 by 5, I get 4, and if I divide 4 by 5, I get 4/5. So what would my next term be? Well, my next term would be 4/5 divided by 5, right? Or, in this situation, if I'm going to divide by 5, it's 4/5 times 1/5, because I have to flip and multiply, and that becomes 4/25. Okay? So this helps me to see that not only am I dividing by 5, but I'm actually multiplying by 1/5. Multiply by 1/5. Because dividing by 5 is the same thing as multiplying by 1/5. Let's do the next one. 1, 4, 9, 16, 25. 1, 4, 9, 16, 25. Do you see a pattern? Well, this one's a little bit trickier, but you can see that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Do you see the pattern? I take each term number, term 1, 2, 3, or 4, and I multiply it by itself, and I get the term, okay? Or I get the amount of the term. So what would the next pattern be? The next term would be 6 squared, which is 36, okay? Let's look at 500, 400, 300, 200. See if you can tell me what the pattern is. Well, from 500 to 400, I subtracted 100, didn't I? From 400 to 300, I subtracted 100. From 300 to 200, I subtracted 100. So what would the next term be? 100, because I'm just subtracting 100. I could also say that I'm adding negative 100, right? add negative 100, add negative 100. I'm only making you see the differences that it's an add or subtract or a multiply or divide, because we'll use that in our next lesson. Let's look at this next one. 1, 1, 2, 3, 5, 8. Do you see the pattern? Well, what I'm doing is I'm adding the two terms. 1 plus 1 makes 2. 1 plus 2 makes 3. 2 plus 3 makes 5. And 3 plus 5 makes 8. So I'm not adding the same number, I'm definitely adding, but I'm adding the two previous terms. So term 1 and term 2 get added together to make term 3. Term 2 and 3 get added together to make term 4. 3 and 4 make term 5. 4 and 5 make term 1, 2, 3, 4, 5. Yeah, make term 6. So how would I get term 7? Well, I have to add 5 and 8. 5 and 8 make 13. All right. Now, those were all just a series of numbers, but we can actually see a sequence in a word problem as well. Look at this word problem. Scott decides to add push-ups to his fitness routine. He starts on day 1 doing 3 push-ups. He adds 2 additional push-ups each day. So I'm going to, instead of writing it out this way, I'm going to make a little table. And I'm going to say day 1 and push-ups. Okay, so on day 1, he did how many push-ups? He did 3. On day 2, how many push-ups did he do? Well, he added 2 additional push-ups each day. So that means on day 2, he did 3 plus 2 makes 5. On day 3, he did 5 plus 2, and that would give me 7. And on day 4, he would do 9, right? So how many would he do on day 5? We said on 4 he would do 9, so on day 5 he would do 11. We could write this as a sequence like this. 1, not 1, 1. This is the day number. We're writing the actual push-ups in the sequence. So 3, 5, 7, 9, 11. Okay? So we could actually create a sequence, all right? Now, as we look at our sequences, we should notice that there are different types of sequences. Some sequences we add things, some sequences we multiply. So some sequences we add or subtract, some sequences we multiply or divide, and some sequences we don't do either. All right? So I want to teach you about 2 different sequences. One is called an arithmetic sequence. The other is called a geometric sequence. An arithmetic sequence always adds or subtracts the same number over and over. All right? So looking here, let's see if we can identify which of these patterns is an arithmetic sequence. I'm going to put a big A by them. See if you can find them. Well, this first one, I added 4 over and over. Each time I added the same number. So I'm going to say that's an arithmetic sequence. Okay? Do we see any others that are arithmetic sequences? Well, this one right here is, because I added negative 100, or I subtracted 100. I added negative 100. So this one was arithmetic, and this one was arithmetic. You might have thought that this one down here, the 1, 1, 2, 3, 5, 8, was arithmetic, but it's not. That is, it's because I'm not adding the same number. And then let's take a look at geometric sequences. Geometric sequences multiply or divide by the same number over and over again. So let's see if we can find our geometric sequences. Well, this one is geometric because I multiplied by 2, and this one right here is geometric because I multiplied by 1 1/5, or divided by 5. I'm about to run out of time, so you can keep watching if you want on the next video.